I'll be talking about our process called Failure Fridays that we run at PagerDuty, and basically the idea behind it is we try to preempt failures by injecting failures ourselves. So I'm Stevenson Jean-Pierre, I go by SJP. I'm a senior engineering manager at PagerDuty. By show of hands, how many of y'all have been on call for production services before? How many of y'all have used PagerDuty? Cool. PagerDuty is a incident response platform. We're basically the 911 center for companies to run their incidents through. Whenever systems or services go down, PagerDuty is that last mile delivery to make sure that the right engineers, the right teams get called in for the incidents. We do more than just incident response though. We have AI ops and runbook automation, which is how do we automatically solve the incidents for you if things go wrong, right? We can preset some automation to do certain things like restart services or do other things that you would normally do as an engineer to respond to an on-call incident that goes on. So one of the reasons that PagerDuty really cares about reliability and resilience is because we have to be on 24 hours a day no matter what, because we are literally the last line of defense for most organizations when they're having their own terrible incidents or they're having their own issues. So we can't introduce downtime into our environments. We can't have situations where we're also down when somebody really needs us to be up so we can alert them that something is going on. So no matter the gravity of the maintenance that we're doing, no matter how big the infrastructure changes are that we're doing or application changes are that we're doing, we have no concept of scheduled maintenance or downtime planned or anything like that as an organization. And that really drives the way that we do change management at PagerDuty, because we don't have the luxury of just saying we'll take the platform down for an hour to do certain types of operations. We all know that failure is inevitable, or I think most people should know at this point that failure is inevitable in a production environment, no matter how much engineering resources you have applied to your company, no matter how well funded you are, no matter how big of an organization you are. At some point, your services are going to fail in production for various reasons. Sometimes they're predictable, sometimes they're unknowable, but no matter who you are, you're not impervious to failure. What's important from my perspective, though, is that when you do have those failures, that you make them count. You take the lessons that you're able to learn from those failures and you apply them in a way to at least mitigate that particular type of failure from occurring again in the future. There's this idea that I could out-engineer these failure situations, right? I could just make better software and that should account for reliability and things like that. But in the current landscape of software development, our systems have gotten so complex that individual components of your software being super reliable isn't enough to make your system as a whole reliable, right? Because that piece of software is just one component in a broader system. There was this talk that Monzo gave a few years ago about their microservice landscape, and this was literally their graph of microservice interactions, and I thought it was mind-blowing to just see the number of connection points that there are there. So no matter how well these teams work independently from each other and how well their services individually work, there's no way that you're going to be able to predict the emergent behavior of systems like this when you reach this level of complexity. So at the end of the day, all you could really rely on is trying to do your best to understand how things will fail and preempt those failures yourself. So at PagerDuty, we run a process called Failure Friday, and basically the idea of Failure Friday is we're going to inject failure ourselves in certain ways in order to make sure that we understand how our systems fail before we give them an opportunity to fail independently by surprise in production. So we break things in a controlled manner so we can understand how to put them back together. This isn't a new concept. If you think about comparisons in the real world, fire departments burn buildings all the time in order to understand how to better train their firefighters to account for these situations, whether they're different types of hazmat situations or different type of buildings or something like that. They're going to intentionally train their employees by putting fires in places and then figuring out the best tactics and strategies for putting those fires out or securing victims or other things like that. In automotive science, they do crash tests all the time, right? To understand how these systems fail in the real world. They don't just rely on the engineering specs for the materials themselves or the car itself. They're going to actually do a crash test in order to understand in the real world, in a real impact situation, what are the ways that these systems fail? What are the ways that the components fail? So Failure Friday or any kind of failure injection testing is no different from these practices in the real world. So the way that we got introduced to the idea of failing or failure injection is back in 2011, Netflix had this concept of a simian army, and they called them their chaos monkeys, and various chaos monkeys would do certain things. You would have ones that are responsible for killing services or killing applications. You would have other chaos monkeys responsible for shutting down servers, or you would have their chaos gorilla that was responsible for shutting down an entire data center. But the idea was preemptively inject failure into your environment and see how your systems react, and then produce automation, produce strategies, produce runbooks, produce whatever is necessary to account for those failure modes and do something about it. So at PagerDuty, our first introduction into similar concept, we didn't go quite as far as Netflix went with their chaos engineering. They had automation taking care of these things all the time. For us, we decided to mimic some of those processes, but keep it pretty simple. So the way that we would do it is that our humans would collect into a meeting for an hour, and during that time, we would have our SRE teams and our development teams, basically all of engineering in the meeting, and we would pick the systems and services that were to be tested or have the failures injected. We would select the failure modes that we planned on attempting on those particular services, and then we would basically communicate these things out to the rest of the organization, make sure everybody knows, hey, we're going to be doing these tests in production, we're going to be doing these things in production, and make sure that nobody's caught by surprise that something actually went wrong when we do that. And then as we run the scenarios, we would learn lessons, we would identify gaps in our understanding of our own systems and things like that, and that would allow us to build better mental models about how the particular systems fail or how they work in general, and it would also allow us to preemptively write bug tickets or whatever else is necessary to remediate those situations. So we had a few failure modes that I mentioned earlier. One type is a just process failure, right? What would happen if your primary database suddenly loses its database process, right? How would your database respond? How would your applications that connect to that database respond? How would the overall architecture respond to that situation? And it's easy to think that, oh, it was just reconnect once the process is back up, but a lot of applications might just die themselves after trying to establish our connections to their database. So we started with rudimentary tests like that, where we would kill critical services on critical machines and see how the rest of the infrastructure responded to that. And not only how the infrastructure responded to it, but how would the engineers that are responsible for bringing these services back up respond to those situations in the real world and bring these systems back up. And eventually what it leads to is that we start automating the remediation for some of these situations so that you don't have to respond to them, and that's the place that we always want to be in. We want to be in a place of auto-healing infrastructure or services that are able to get back up on their own without human intervention, because human intervention time always costs us a lot more time than you expect. We would have host failure. So what happens if a host completely disappears from our infrastructure, a critical host, whether that's a database node or a Kafka node or even one of your Kubernetes cluster members? Like, what would it look like if a host completely disappears? In the world of Kubernetes, if half your pods disappeared for a particular service, what would that look like? How would your production load be affected? What would be the downstream impact of losing half of your capacity, for example? So even till this day, that sort of testing is super important for us, because we get to understand not only how our systems scale, but when they do incur these thundering herd type issues or suddenly have to deal with a lot more traffic than they're designed to, what happens and how do they gracefully degrade? Network isolation. This is one that I think if you've ever been in any kind of cloud environment, you know that every so often you might have situations where your availability zone or your region or something in AWS might have an issue that segments your network in a way that you don't expect. It's not that these services are down or the machines are down, but they just can't talk to each other. What happens to your quorum algorithms? What happens to the ways that your machines talk to each other? And if they lose that connection, what happens to that split brain, right? Who wins that race? Who decides to still be the primary? Who still decides to be the leader? So injecting that sort of failure teaches us a lot about distributed systems and how they react to things. And of course, CAP theorem comes into play and a bunch of other stuff, but you want to have predictable outcomes to these situations rather than just waiting for the chaos to ensue. Network degradation, the example I wrote there is like, what if all your latency across the board increased by 2x or 200%? Would you be able to identify the source of that latency? Would you even have your application able to handle that? What would be the downstream impact to all the applications that depend on that application that's suffering from the latency? Would they all end up having the same type of domino effect where now that your primary service is latent, does that make the rest of your solution also suffer from that same sort of degradation? And resource exhaustion, that's a common one, right? Like, what happens if your disk is full? What happens if you run out of memory? What happens if you're pegging your CPU for too much time? How does your application behave? What are the error messages that you expect to see in your log files? What are the ways that you can identify these situations as they happen? And what we found oftentimes is we know mentally how to deal with these situations, but the identification of these situations is hard to do, right? So you might have a resource exhaustion issue. Let's say your hard drive is full and you can't write to that disk anymore. It might show up in the oddest ways in your system, right? Because not every part of your system might be writing log files or writing to the disk, and the first thing that tries writing to the disk or try getting some inode is the thing that fails, and it fails with a cryptic error message. Are you able to reason about the error messages that you're seeing and understand the true cause of it? But by injecting these sort of failures, we're able to not only understand like how this application fails, what sort of heuristics we're going to see in production around these things, but we're able to then tailor our alerting and monitoring to make sure that once these situations do occur, we have easy identification for them and we know exactly what type of things are going on with it. So this is from back in 2013, how we ran our failure Friday processes. Basically, we would pick a type of failure to do. In this particular one, this was injecting latency into our database systems. We were running Cassandra at the time, and we were injecting latency and just basically seeing how the system reacted to that. And that's just a screenshot of a portion of the conversation from this. Of course, I wasn't at PagerDuty back in 2013, so I had to do a bit of like archaeology to get some of this stuff. But this is like the first kind of iteration that we did around failure injection and testing. And it's scary, right? You're injecting latency into your database subsystem in production, and you're trying to see how the system behaves. And then around 2015, we started having, like, chatbots were all the rage back then. So we got our chatbot that's still around called Officer Earl, and basically we were able to do some of the failure injection using this mechanism. So we do things like isolate machines or reboot machines or just drop a process from a machine using our chatbot, which allowed us to have an easier interface into some of these, because when we first started, we were having to SSH into the machines themselves and do some of these practices, but getting a chatbot made things easy. And then we started letting these things pick the machines themselves, right? So it was a sort of roulette. We're saying in production, pick a machine and do something to it, right? Whether that's stopping a process, triggering network latency, or doing other things, and the bot would pick its victim and then start the process. And that allowed us a bit more just chaos and knowing like the system's going to be picked at random, the type of failure is going to be picked at random, are our alerts going to fire off correctly, are the right things going to be visible for us to understand the failure in the way that we've described it. And then things got more automated. We had something called Chaos Cat that would just pick a machine out the blue, like on any given day, just pick a machine and do something terrible to it and see how our engineers would react, see how our infrastructure would react. But I thought it was pretty cool when I first joined PagerDuty when I saw Chaos Cat in action, because you'll just be in this random channel and it's like, I just picked my database server as a victim and it'll do something to it, and it'll be in the middle of your day and you'll just have to deal with it. But I think what it allowed us to kind of truly embed in our thinking is that nothing is like, you can't take anything for granted when it comes to reliability. AWS is notorious for having maintenance events for your systems, and it's saying, hey, this machine's going away in 3 hours, or even if you get that notice, because sometimes you'll get a ex post facto kind of notice that says your machine went away and you just have to deal with it. So in a cloud environment, things are way less kind of static. So we have to get just used to the idea that everything is ephemeral, nothing is your pet. You have to make sure that you have the capability to reprovision these machines, or at least quickly remediate the situations that come up with these machines. And Chaos Cat really allowed us to do that, because it was picking victims at random to do these things too. So every so often we would truly cause production issues, right? So there's the failure injection we're doing, and sometimes we would actually cause incidents, and we would have to convert ourselves from this idea that we're just doing a failure Friday to running a full-blown incident because we caused the issue that was bad enough that our customers would notice, right? So we've done failovers that haven't gone quite right, or we've done other actions in our production environment that led to actual customer impact, but the percentage of issues that actually led to customer impact has been super low even over time, because we try our best to like plan these things out and make sure that we have the right set of kind of guards in place to not impact our customers. But sometimes we're in a full-blown incident and we have to admit, like, yeah, we killed the database and the database didn't come back up in the way that we needed it to. But we learn a ton of lessons from those situations, and they model the real world, right? So there's nothing to be kind of disheartened by when you actually encounter situations where you have to admit that we might have went too far and we might have broken things in a way that required more effort than we expected. So I mentioned earlier that building reliable software isn't enough, right? Because the software in itself is an individual component in your overall infrastructure. So what you have to do is take a systems mindset to your infrastructure, to your applications, to your entire stack. You have to build reliable systems, because your systems include your humans that are involved. It includes the software components. It includes the network. It involves everything that is related to you bringing a solution to production, right? So you have to think about these things systemically. You have to think about how your humans interface with these things. You have to think about how the individual bits of software interface with these things. You have to think about how your cloud architecture and your system design in general accounts for these failure modes and can auto-heal or auto-remediate themselves when they do encounter failures. So the thing that we're really chasing by doing all this is improving our mean time to resolution. Over time, our expectation is that as we inject our own failure, as we practice these things, we get way better at dealing with real world situations. We get way better at dealing with the incidents as they come. And the effect that we're chasing is that if an incident does happen, we're either dealing with it so well that nobody ever notices because it's mitigated somewhere upstream, it's mitigated somewhere in our high availability design or disaster recovery design or something else, so that we don't actually have to notice because we've built enough redundancy and resiliency in our systems. Or when we do truly get into an incident state, we're able to identify and solve the issue within a really quick amount of time, so that even our customers won't notice, even though we might, right? So the thing that we're always chasing is that mean time to resolution, which is that if you take that sum total of times that you had incidents for a given month and you divide that by the number of incidents, we target a certain number. We try to get our mean time to resolution to be below 10 minutes for a production issue, and that allows us to take more risk in production. We're able to move faster because we can rely on these systems. We solve for the kind of unpredictable issues to the best that we can, so that we can spend our error budgets doing more innovative things with our software, with our deployments, and making sure that we're able to push features faster because we know we have these quick turnaround capabilities. So we started the process off by calling it Failure Friday, but what it really turned into is failure any day. We do these things continuously throughout the week. It's no longer just confined to a particular day of the week. Any team within our engineering organization could put together a plan for their failure testing and run it at any given time in a day. The process has evolved over time. What's interesting is we no longer rely on things like Chaos Cat and things like that, because we've gotten to the place where we are confident enough in our auto remediation capabilities and some of the other things that we've put in place that level of testing is no longer what we're pursuing, because that's now the low-hanging fruit for us. So what our process has turned into is a more formalized, almost like scientific process, where we come up with a set of experiments for a given system or service. We design test plans around that. We design these rollback capabilities around that. And then we carry out our experiments, whether that's load testing, database failovers. We practice a lot of our, not practice, it's production, so I guess it's not practice, but we do a lot of our, if we're doing a large scale change, last year we moved all of our compute infrastructure from HashiCorp's Nomad to Kubernetes, and that happened throughout the year with zero downtime, without a single kind of blip, and our way for doing that is by incorporating our Failure Friday processes into how we did that migration, so that we can be assured that we're following a process that's like reliable and actually like thought through. So when we're doing big production changes, instead of taking downtime, instead of setting maintenance windows, we'll use our Failure Friday process to make sure that we're incorporating some of these things. And we've incorporated our incident commanders into our Failure Friday process, so that each Failure Friday is an opportunity for our incident commanders to also be present. So if a failure injection test does turn into a full-blown incident, you already have all the context and all the people that are necessary there to just roll into the incident call without missing a beat. There's some additional benefits to the style of failure testing or failure injection that we do. We found that it's great for team member onboarding. No matter how much documentation or runbooks or whatever that you have for your services, it's really hard to teach new people on a team how to think about systems, or how to have that kind of mental model of the system and how it really works in production. There's what your documentation says, and then there's the way that your system actually works. And many people often find that the documentation doesn't align with how your system actually works in production. But by having new members of a team be involved in these kind of failure injections, they get a first-hand experience of how the system truly behaves, and that helps them build their mental model way quicker than just reading some documentation, or way quicker than just kind of being a backseat observer of how these systems operate in peacetime, because that's not really how you build context about systems. When they're just working and they're working fine, you're rarely digging into the kind of subsystems. You're rarely digging into like how things operate. You're just happy that they're working fine. But when things are breaking and you have to truly troubleshoot them, it allows you to do a deep dive into these systems and get to know them better. So we found that our engineers are able to onboard onto teams and onto particular services much faster because we do these practices with them. So when people are joining our teams, part of their onboarding is to run some of these Failure Fridays to make sure that they are getting some of that benefit from the process. It forces us to continuously update our documentation. We all know that as soon as you publish some documentation, it becomes stale, and you go back a day later and it's already out of date based on something that changed in the system. By continuously running these kind of failure tests, failure scenarios, we always have to refer back to particular runbooks or particular automation that we have for solving certain issues, and that is it forces us to always be aligned in making sure that those things actually match up with the real world, because as you try to run them, if you find out that, for example, this Kubernetes migration I mentioned, when we moved from Nomad, some of our runbooks still had like how to do things in Nomad or how to automate things against Nomad, and we were forced to have to update a lot of those things in real time to the Kubernetes version because we had to run these Failure Fridays against them. So it doesn't allow our documentation and our runbooks to stagnate as much as they traditionally would in a normal environment. It's perfect training for incident commanders. I mentioned that we have this cohort of folks that we call our incident commanders, and they're basically the person that helps coordinate our incident response when we are in a situation where we have some production outage or some production situation. And usually, or if we didn't have Failure Friday, the first time an incident commander would be able to practice their skill would be during a live incident. They would be kind of fumbling around and trying to, get the reins of things. But because we have this Failure Friday process that very closely mimics how we run our proper incidents, they're able to get that practice beforehand. They're able to command a room. They're able to make sure that multiple teams are following different paths of investigation, so that when we get to a real world situation, they're able to take that learning that they had from our Failure Friday processes into a real world incident. It helps build strong team culture. It allows a lot of great cross-team collaboration and communication. I think when our junior engineers are watching some of our senior engineers work and how the processes that they use for troubleshooting, the processes that they use for systemically identifying what could be the problem and things like that, it allows people to absorb from each other and learn from each other in a way that I hadn't necessarily seen with other practices. So I think all organizations have teams that aren't quite the same level of efficiency, right? So sometimes you'll have some super high performing teams and some teams that aren't as high performing, but by bringing the teams together to do these things together, I think they get to learn from each other and you get, on average, better performing teams. It's great for getting practice writing our postmortem. So every failure Friday that we do or failure any day that we do, there's a report that we generate at the end of the process, which is a miniature postmortem. You talk about the failure, you talk about what we saw, we talked about the things that surprised us as part of it. Sometimes we'll do one type of failure and then the effect that it has is way different than we expected it, and those are surprising things that we want to document. So it gives us an opportunity to write these reports, learn how to write good narratives around like failures, and making sure that when we do encounter real life failure situations, we're able to build these narratives in the same way and have high quality standards for these outputs. And then it fosters system thinking. Earlier during the keynote, she was talking about systems thinking, and I thought it was really cool because this is this concept that I keep trying to get people to think about. It's easy to be very tactical in your day-to-day life when you're thinking about how your system works, when you're thinking about how your system fails, and when you're thinking about the individual components of your system. So something that we've had to do with this sort of failure testing is say, if we see one type of failure in a given system that matches a particular design pattern or something like that, it would behoove us to like look at all the other systems that is in our infrastructure that follows the same design pattern and see if they're vulnerable to the same type of failure. Because what we hate to have happen is that we see a particular type of failure on Monday, and on Tuesday we're seeing the same failure in a different system because we didn't take the time to look through all the other places that the same type of thing may have been experienced. So when we zoom out a little bit and we take like a systems mindset to things and we think about our individual processes as a broader system, a lesson learned in one corner could be applied across the board, and we have to always take that systemic view that this isn't just like a unicorn in our infrastructure that exists on its own. We have to think about all the other places that this may show up. Or we could think about the different permutations of this type of incident that we can like reasonably predict would affect other systems, and that allows us to be more proactive about how we design software, our design philosophies and architecture, and how we make things consistent across our infrastructure. We run hundreds of microservices, and nobody should like have the hubris to say like, oh, that happened over there to that microservice. It can't happen to me. If you're following some of the same design patterns, of course it's going to happen to you. It's just a matter of when. So when we learn those lessons one place, we could apply it somewhere else. And system thinking really matters at the end of the day because it allows you to extract those patterns like I was mentioning. She had an iceberg. I think this is a triangle, same, there's a water line, so it's an iceberg too, I guess, just a very angular one. But basically, it forces everybody involved in the process to think about these things as a more holistic narrative. It's not only the individual trigger point that we set off that is what the incident is, it's about all the contributing factors, and sometimes contributing factors aren't technical at all. Sometimes we go back through an incident or through a particular failure and we realize that maybe we're not doing the right things with our architecture patterns. We're not doing the right things to stay up with the latest and high availability design for a given cloud system that we have deployed. There's often times that in most infrastructure, you're not only running the code that you wrote, you're also running the cloud services that Amazon provides, or you're running Azure services and things like that. And not a lot of people potentially take time to deep dive into like, what are the best high availability designs for these things, or what are the best ways to deploy these things to make sure that they're resilient. But if you constantly take a systems thinking mindset and you think about the more holistic kind of view of your infrastructure, all these things matter equally. It's not just the application that your teams wrote that are the points of failure or points of contributing factors to these incidents, but everything plays together. And the more you think about how these things interact and how these things show up for each other or cause each other to fail, it allows you to have just a way better kind of unified thinking process for your engineering organization, and making sure that they're able to not only adequately design experiments for these kind of failure injection scenarios, but also in the way that they write software, they start being more defensive in like some of the ways that they do things, because it's really easy to be naive about, oh, this system will always be available, so I'll always just write here, or I'll always just make this API call. But then you start incorporating patterns like circuit breakers and exponential backoffs and things like that to allow your systems to gracefully degrade and also recover once these systems come back up. So in summary, failures will always happen, so the best you can do is make sure that you're preempting them by understanding that they'll happen and just taking it for granted that they will happen, and making sure that you're not only producing defensive strategies against these things, but actively pursuing what it looks like to be excellent in production systems. Plans only exist if they're tested. So I know a lot of people have backup strategies and plans and DR plans that they never test. And then when the time comes where they're truly in a disaster or truly in a situation where they need to recover their backups, they don't actually have backups, or they haven't worked in years because they haven't tested them. So your plan is only as good as how often you test it. So make sure that you're testing your plans often. With the Failure Friday and Failure Any Day strategy, you could start small. Like we mentioned, when we first started, people were SSHing into these machines and killing processes themselves. So there's no need for the full Netflix approach at the beginning of creating automation to do these things. You can start very small. What's important is that you start thinking about your systems as a series of systems or series of components that all work together to form one bigger system. And once you get that mindset and you start trying to do your own failure injection, you'll realize that there's a ton of lessons that can be learned that are well outside the technical realm, that are just about how the teams interact with these services, or how the understanding of these services allow for you to quickly resolve these issues. And the other point is just have fun. There's a lot of great lessons learned that we've encountered, a lot of good innovation that's come out of doing some of these processes. So it's really fun to dive in and do some of these things. So if you do decide to start doing this stuff, it's going to be pretty fun. It's going to be I don't know, it's really stimulating to have these situations. Whenever you're in a real incident, your blood's pumping, there's a lot of things going on. I know it's not for everybody, it creates anxiety in a lot of people, but once you get past the anxiety, it's really cool to have to deal with these situations in real time. And that's all I had. I'm open for questions. Hopefully, I don't know how much time I spent, but questions? Cool.
So I've never dealt on systems as big as yours. But so I've always had a test system that's identical to the production system, and so I could always theoretically test things on the test system. So I'm assuming your system's so big you couldn't have a test system we could accurately reproduce.
So you know how you said theoretically? When you say it's identical to production, it has production customers going to that test system?
No, but I'd run production, old production data against it.
Including the traffic patterns and the ebbs and flows of the traffic patterns and the other things like that. It's really hard to replicate a production environment, is what we found. I've tried for years. I've been in the SRE, reliability space for years, and we've done shadow load, we've done all these things, but customer traffic, in my experience, has been absolutely unpredictable. Customers would do the weirdest things, and yes, you could play back traffic and get an approximation, but we've been so surprised in production so often because this one customer decided to load this one page and somehow they put 1,000 users in the same group or something like that. It's these things are really unpredictable for us, so I prefer to do things in production because that's the only environment that's like production. For certain load tests, sure, we'll do a approximate load in our load test environment just to see how an individual subsystem might react. But when it comes to holistically looking at a system like production and seeing this customer flow over here turns into this system flow over here, I've never been able to truly replicate production in that way, and we've done our best to approximate it, but nothing beats actual production for me.
Okay, thank you.
Hi, I have two questions, and also the same thing. We used to do the whole mirroring production, and it just never worked at all. The environment's always just decayed and became unrepairable and just abandoned. So I kind of get why you do in production. But what about the issues where, say, Chaos Cat says, okay, a user got access to the database and deleted all the data and that got replicated? Scenarios where it's going to take maybe more than 10 minutes to repair. Yeah. What do you do in those scenarios?
Yeah, Chaos Cat was never that chaotic like that. That's downright malicious at that point. But yeah, we never simulated things like data corruption or data deletion in that kind of way. What we were worried about more was I think those are already understood to be super anomalous situations. So those weren't the type of experiments that we were particularly chasing. We were chasing how do our individual components or how do our systems fail in a reproducible way. Yes, data could be deleted and we know that requires a restore, but even some of those restore processes we test independently through the new version of Failure Any Day where we do the hypothesis and experiment and stuff like that. So we have we've had systems where not because of like malicious actors, but because we weren't doing soft deletes. When a customer goes to delete something, it actually gets rid of it in the database, and then the customer comes back 12 hours later like, well, I accidentally hit a button and it deleted 1,000 records from my database. How do I get this back? And what we ended up doing is, after we've had enough of these situations, we're like, hey, this is now a requirement in your software. We're moving to soft deletes with a time delay before the hard delete, and we need a way to like automate the restoring of particular resources once they're deleted, and that really allowed us to free up our engineering time, because what we're always trying to do is shift things from being ops work to being engineering work, right? So if we find ourselves doing the same ops work often enough, like we have to restore this logical dump, we have to move this data from a CSV to back into the database, we then say this needs to go on the engineering roadmap and this needs to become a feature of the application. So that's how we've dealt with some of those situations in the past.
This is a second quick question, hopefully. Sometimes when we would have new SRE people come into, they would like be with the company for a little while, and then they would be like, okay, you're on PagerDuty rotation, and then that's the day, prod goes down, and then they have like 1,000-yard stare, like everybody's going like, what do you do? And he doesn't know what, or he or she doesn't know what to do. Does this kind of like make PagerDuty a little bit less like stressful for like new people coming in?
I think so.
Because they're used to it, I guess.
Yeah, I think so. Like I mentioned, as part of the onboarding for every engineer, you're going to run a few Failure Fridays for your team. So I think the kind of destigmatizing of production in that way, like you're like, hey, it's production, but you're going to break it. You're going to break something, and like getting them comfortable with the idea that like things are breaking all the time. You don't have to feel bad that you might have broke something, or you're going to break something eventually. If you haven't broke something in production, you haven't tried hard enough, right? So by getting them as part of their onboarding, even for junior engineers doing these things, you destigmatize it so that they don't end up with that kind of shell shock that you're describing. But also they realize that we have a ton of systems in place, we have a ton of run books, we have a ton of documentation in place. They get the practice of, how do I find this thing? Where do I find this run book for this particular situation? It makes it much easier for them to come to the realization that it's all like pretty straightforward, and it's not going to be like a super disastrous event if something does happen.
Thank you so much.
Hi, first of all, thanks so much. Like, amazing talk, like really confidence inspiring as a PagerDuty user, like awesome.
Thank you.
I really quickly wanted to ask about how you conceptualize like coverage. If you think of this as like testing, like how do you make sure that you're covering all the bases, that you have tests that run everything?
That's a good question. I think we've recently been doing more work in trying to like make sure we can quantify coverage, and the way that I've been thinking about it is how many teams are running these failure scenarios and how often they're running them. I had pulled a stat while I was putting together the slides, but we ran like 300 plus of these failure scenarios in the past like 2 years. And I was like, that's pretty good, but what I'd like to see is a breakdown of like which teams and services have been tested, what failure modes have been tested as part of that. And we could do a lot better like reporting on some of that stuff, because it's all detailed in our post-incident like notes and reviews and stuff like that, but we don't have this quantification of like, this is 98% covered or anything like that, because by its very nature, a lot of it's gonna be like a lot more random than like, there's no list I can go to and say, all these systems have been covered. I can guarantee that this type of failure won't happen. It's like, I can guarantee these basic failure modes won't happen in a like predictable fashion. And our goal at the end of the day is to have as many novel incidents in production as possible, right? I don't want to go to an incident call and realize that a disk is out of space, or I don't want to go to an incident call and realize that we didn't have this thing deployed in triplicate and that's why the service went down. So as we do better in this, what we should see as a kind of metric is that we're taking longer to resolve incidents, because the things that we're actually encountering in production are things that are truly novel to us, that we don't have runbooks for, that we haven't encountered before, and they truly require like a certain degree of engineering and investigation to truly solve.
I understand the importance of running things in production, because nothing mirrors production like production, but that can be really scary for some industries like healthcare or finance that don't like messing with their production data. What are some of the guardrails that you put up to make sure that to like limit the blast radius of some of these and make sure it doesn't go from an experiment into an incident?
Yeah, that's a really good question. I'm really glad I don't work like in healthcare, because I think I think oftentimes the way I try to describe it to my teams, especially the people that get nervous, I'm like, at the end of the day, like it's not heart surgery. It's not like, you know what I mean? So we always compare to healthcare where we're saying like, at the end of the day, at least we're not doing X, Y, Z. But I think there's a certain amount of buy-in that you have to get from your leadership, from your organization, right? You have to be like all kind of aligned with these things. And of course, you don't have to start in production, right? You could start in your staging environment. You could start in the systems that have like replicated data and stuff like that. But if your production environment is truly unique, truly a snowflake and things like that, at some point you're doing yourself a disservice by not doing these things in your production environment, because they're gonna happen regardless, right? You're gonna have an outage because some power failure happened at some data center at something and you had no reasonable approach for solving it because you never tested these scenarios. But once you have that buy-in, I think limiting blast radius can happen in a few ways. In the ways that you design the experiment, you could start really, really tiny and work your way up. You could think about how you architect your systems. Are you building them with high availability designs? And if you are, then taking out individual nodes or individual components of that shouldn't have any impact, right? So I think there are ways to reason about it that way that comes in handy. And I don't know in the healthcare field if there's like low seasons or downs or like seasons where things are a little more relaxed where you can potentially take an outage, but that's not, I've worked in the financial tech sector before, and every minute we were down, people were losing money, and that was like, in my mind, almost, not equally because lives were at stake in healthcare, but it was like equally kind of risky doing it there. But if we agree that it's inevitable that failure is going to happen, I think preempting it is just something that you have to get that kind of socio-technical buy-in and make sure that everybody just agrees that like, hey, it's going to happen. You're going to crash the car at some point, so let's make sure we pre-crashed it to make sure we understand how it fails. And it may hurt at first. It may cause some people to be upset because you had a 2-day outage of your Epic system or whatever the kind of EMR systems are, but at the end of the day, it's going to happen and you need to be able to account for it. So you could start off in non-production environments and you would have to spend more effort getting those environments to match production, but I don't know, it's a hard thing to kind of balance between.
So, quick question. Do you incorporate customer impact metrics into your experiments? So, for example, page was delayed by 5 minutes, 10 minutes, 15 minutes.
Oh, yeah, for sure. Every single one of our incidents, every way that we think about incidents is like, customer impact is like how we even determine incident severity or potential severity for an incident, right? And we're definitely not dealing in the court, like in the scale of minutes for any type of customer impact. If we're in that position, we've totally failed in the way that we're doing things. But yeah, customer impact is like one of our primary like metrics or attributes that we look at when it comes to incidents. And if we're talking about blast radius, customer impact is already understood even from individual services. It's like this service being down has the ability to impact X number of customers, right? We know our usage numbers. Not every customer uses every feature. So if a particular like well-used feature is something that comes under scrutiny, then we already understand what the maximum impact is potentially there. And then the work that we have to do is like reduce that customer impact as best as possible by incorporating whatever design patterns, whatever things we can do to make sure that these systems fail gracefully.
Okay, and following on with that, do you do postmortems that you track actual customer impact? So, for example, you say this system could have this impact, but to find the unknown impact that, okay, this page was supposed to go out, do you track every page from we have the condition that should have triggered it, and it was triggered here, so that you know after the fact, yeah, we didn't miss anything?
Yeah, it's part of our SLA. Customers get credits when we're like not able to reach our SLA, so we have the ability to track some of these things in the way that we're saying, like after the incident, after the dust is settled, we have reports that we could run to see how many notifications were out of SLA or how many notifications were delayed by X, and we could tell you exactly, like we could bucket them saying like these were delayed by 5 seconds, these were delayed by 5 minutes or something like that. So we can always kind of like forensic investigation, rebuild and understand like what the true impact was for these things. And some of them where we think are like really terrible incidents, we realize that, oh, the customer impact wasn't actually that bad because we had these levels of mitigation in place that kind of buffered for the customer.
Thank you. I wanted to piggyback off of this gentleman's question here. He actually stole my thunder. It was a great question, by the way. But did you get any pushback in trying to push this idea of like Chaos Monkey, bringing things down in production from your leadership? I know obviously you have to sell it, but as it's making its way up to where you're actually affecting production, just curious of any resistance that you all might have faced or continue to face in the wake of this process.
So I got really lucky. By the time I joined PagerDuty, this was a practice that they were basically introducing to me, right? So like I was just as surprised as everybody else when I got there, and I was like, oh, we're doing this in production, and it's a regular Tuesday or something like that. I'm like, this is the type of thing I want to stay away from. And I come into this place, they're like, yeah, take it down, and it was just already part of the culture. So I got really lucky in that way. At my previous organization, we were doing these kind of things in a staging environment, and we were having all those issues with like trying to mimic production load, because we would do stuff in staging, we'd spend days getting it right, and then we'd deploy it to production, and it breaks in a catastrophic way. And we're like, we did all the testing and staging, why didn't this thing reveal itself? And it's like, well, production has these very specific kind of emergent kind of behaviors that you just can't reproduce. And it was always so frustrating to be in those situations. So to get to PagerDuty and see that everybody was bought in, I mean, the CTO, the VPs, everybody was bought into this idea, and they were like just almost like so flippant about it. Like, oh yeah, just do it in production. I was like, no, why would you do that? But so I had to come around to it more than my leadership had to.
It's definitely a tough idea to sell. I have been trying to do the same. But
Yeah, I definitely think it's a tough thing to sell. But I think you have to, if your requirements are like, as our requirements are, like we have to be up, like you really don't have an option, then you have to invest in like these more chaotic or these more kind of innovative ways to make sure that you're building in the resiliency and reliability that you really want. Cool. Thank y'all.